All right, 5, 6, here we go. Okay, so we've actually done 1 through 4. That's actually in chapter 4, so I'm not even gonna worry about those. Let's start with these down here. And again, this is notes 5, 6. Okay, so let's go ahead and look at number, I want to cross off 5 and 6. These notes are kind of long, so I'll kind of do just like a couple of each. So number 7, the first thing I want to do, if you notice on the steps, A and E have the same, they're kind of the same. So you can either find the domain first, at the end, or both. I would prefer to check it at the end. So the first thing I want to do is isolate the log. So I want to get log by itself. So I'm trying to get all this by itself. That means I want to get rid of my 5. So I'm going to divide over the 5. And that gives us 10. Okay, now that the log is by itself, I'm going to change it to exponential form. So this little number down there, that's the base. Whatever is by itself is the exponent, and then it's equal to x. Now we're going to solve. Well, we already solved. X is already by itself. And this would probably be no calculator. It doesn't specify, so we're just going to leave it like that. And now I'm going to check the domain. So if you recall, for the domain, the argument must be greater than 0. Well, this is obviously greater than 0, so I'm good. All right, number 8. So I'm going to get, first of all, the log by itself. And I cannot subtract these because this 3 is attached to the natural log. So I have to work backwards. So first I have to subtract over the 4. And then I have to divide over the -3. All right, now that this is by itself, I'm going to rewrite this in exponential form. So if you have a natural log, e is your base. So I'm going to write this as e to the 4th power equals x. And I already solved, x is already by itself. And then I have to check the domain. So our answer is definitely greater than 0. And just to be certain, I'm thinking ahead about the test day. This could be on the non-calculator part. It might also be on the calculator part. So let's figure out what our answer is in the calculator. So the E button again is above natural log, so second natural log, and I'm going to do e to the 4th. And it's 54.598. 54.598. So this is my exact answer, this is my approximate answer. Okay, moving to the back. Okay, let's go ahead and get rid of number 9. We'll do number 8. Well, 8's kind of the same thing. No, we'll do it. It's fine. Because this is not just x, it's a 2x. Okay, so the first thing I want to do, I'm going to follow my steps from before. I'm going to get the natural log in this case by itself. So to do that, I have to work backwards. So first I have to add over the 5. Then I'm going to divide over the 8. I'm going to assume this is no calculator. And then once this is by itself, I'm going to rewrite this in exponential form. And I can also reduce this to 9/4. So when I rewrite it, I'm going to change that to 9/4. So e to the 9/4 power equals 2x. Well, I have to now still get x by itself. So from this point, I have to divide over the 2. So now x is equal to all of this. But if I want an approximate answer, I would just put that in my calculator. If your calculator doesn't show up as an exponent raised, then you must put your fraction in parentheses. I'm going to do it anyway. And then I'm going to divide it by 2. So 4.743 would be my approximate answer. Okay. All right, let's move on. Let's go ahead and get rid of number 11. Let's look at 12. So same thing, I'm trying to get the natural log by itself. So you want the natural log or the log and then whatever is after it together by itself. All right, so we are going to, first of all, subtract over the 1. And then divide over the -2. So I'm going to leave it as that. Okay, now that this is by itself, I'm going to rewrite that in exponential form. And again, there's an e there. So e to the -19/2 power equals x minus 3. So to get x by itself, you just add the 3 over. So this would be exact form. Okay, approximate form, let's see what we get. So e to the -19/2, and then I'm going to add 3 to that. So about 3. So x is about 3. So I get an approximate answer and, I'm sorry, an exact answer and approximate answer. Okay, 13 and 14. We're going to do both of those because they're different from the ones I just did. We have multiple logs, but this time the logs are on the same side. The ones we did on 5-5, they were on opposite sides, and you could have just canceled those out. But these are on the same side. So the first thing you want to do before you start working backwards is to condense. So this means to multiply the arguments. Okay, so when I condense it down to 1 log and I multiplied the arguments. All right, now it looks like I can distribute the x here. And really all of this goes together. All right, there's nothing else I can do. So in order to solve, I have to first of all rewrite this in exponential form. So 3 to the first power equals x squared minus 2x. All right, well, it looks like in order to get x by itself, since I have an x squared and an x, that means I must factor. So in order to factor, I have to subtract over the 3 because I want it equal to 0. So two numbers that multiply to get -3 and add to get -2 would be -3 and +1. And then as a reminder, I set those equal to 0. I get 3 and -1. However, I haven't been checking my domains, but they've all worked. But now I know I have to check them. So if I go back up here to my problem, I have 2 arguments. I have to make sure that these, if I substitute these in one at a time, that it's greater than 0. If I put 3 here, that's greater than 0. If I put 3 here, that's going to give me 1, which is greater than 0. So 3 works. If I put -1 in here, it doesn't work. So since it doesn't work, I don't have to check that one. So only 3 is the answer. Okay, 14. So first I'm going to condense. So log base 4, I'm going to take x times x plus 3 equals 1. And we're going to distribute again. And really this is grouped together. All right, the next thing I want to do is rewrite this in exponential form. That's the only thing I can do in order to solve. So 4 to the first power equals x squared plus 3x. I have an x squared and an x, so I have to subtract over the 4 because I'm going to have to factor. Two numbers that multiply to get -4, add to get +3. That's going to be a +4 and a -1. If I set these equal to 0, I get -4 and +1. If I put -4 back up into my arguments, I'm not going to get an answer that's greater than 0, so that one doesn't work. If I put 1 up here, it works, so that's just 1. If I put 1 up here, that's 4, which is greater than 0. So 1 is my only answer to 14. Okay. All right, so 15 and 16, that's less than 5, so I'm not even going to do those. We did those on 5, 5. That's why I marked those off. Okay, yeah, this definitely says not to use a calculator now. So I'm going to definitely keep these in exact form. The other ones didn't say. Okay, so my same steps apply here. Now this time the x is in front of the log or natural log. So we're going to solve these a little bit different. Okay, so I am going to, I'll do number 17. So again, x is going to be in front. The ones we just did were after them. So to get x by itself, I am going to divide. Looks like I'm multiplying by 4 and by the natural log of 3. So I can divide by 4, natural log 3. So that is actually my answer. 6 divided by 4, natural log 3. That is my final answer. All right, 18 is the same thing. It just says log this time. Okay, let's look at number 20. So this time this is grouped with the x, so I have to get rid of that stuff last. So the first thing I want to do is get rid of my natural log of 3, so I'm going to divide that over. Okay, so I have 2x plus 1 equals 7 divided by the natural log of 3. The next thing I want to do is subtract over the 1. And the last thing I want to do is divide the 2. So I'm going to take all of this stuff and then divide it by 2. And since it's no calculator, I want to leave it just like that. Okay, 21, it's just like number 20 except it says log. So I have to get rid of this stuff last because that stuff has the x with it. So the first thing I want to do is divide by log 4. So I get 3 minus 4x equals 11 divided by log 4. Okay, now I'm just going to work backwards. I'm going to subtract over the 3. And then the last thing I'm going to do to get x by itself is take all of this stuff and then divide all of that by -4. Okay. All right, so now x is going to be in a different spot, but before we talk about that, recall that the natural log of e is just 1. Make sure you know that. Well, if I do the power rule, the x just comes down in front, which means my answer is just x, because it's x times 1, which is just x. This, the x would still drop down in front because it has a natural log, but this is all I can do because I don't have a natural log of e anywhere. Nothing cancels out, in other words. Okay, so in 23 and 24, I'll just do 23. They're the same, really. So since I have a natural log, or even if I had a log, I'd be able to drop down the exponent. And this is 1, so really I can make that go away, and I'm left with just that. Now we had to review this first before we could do the stuff that's below. Okay, and we can just cross off this. Okay, so here's how we solve where x is in the exponent. So there's three different types of equations that we solved today depending on where the x was. So first we have to make sure that the base and the exponent are by itself. That's what this means, so we're good. In order for me to drop down this exponent down in front, I have to have either a log or a natural log there. We're going to do the natural log. So whatever you do to one side, you got to do to the other because you got to balance your equation. So I'm going to put a natural log on both sides. That allows me now to do the power rule. So the x is going to drop down to the front. And now I'm going to solve for x. So since x is in front, I'm going to divide by the natural log of 5. So this is my answer right here. And this is not the same as a natural log of 4. It doesn't say not to use a calculator, so I'm going to type this in my calculator and see what I get. So natural log of 20, close your parentheses, divided by the natural log of 5, we get 1.861. 1.861. Okay, let's cross off 26. Let's look at 27 though. So it looks like the exponent and the base are already isolated. So I'm on the second step here. I'm going to put a natural log on both sides. That now allows my exponent to drop down in front. Okay, I did the power rule, so these kind of go together. And now I'm going to solve. So what I'm going to do, it kind of looks like the ones that we did on the previous page. So I have to get rid of this stuff last. So first I'm going to divide over the natural log of 3. Then I'm going to add over the 1. And then the last thing I want to do is divide all of that by 3. So take all of that and divide it by 3. So this is my answer. Now let's put that in the calculator, but you got to be careful. So you're going to do natural log of 90. Whoops, that's not right. 90 divided by the natural log of 3. You might want to do that first. Okay, then do plus 1, enter, then do divided by 3. 1.698. So x is about 1.698. Okay, number 28. So I have to first of all get the exponent in the base by itself. So I have to add over the 2 first. Okay, now that it's by itself, I'm going to take the natural log of both sides. That allows my exponent to drop down to the front. Now, a common mistake is that you don't put the natural log on both sides, which you have to. So make sure you put them on both sides. And then to get x by itself, I just divide over natural log of 10. Okay, so this would be my answer in exact form. Let's put that in the calculator and see what we get. Natural log of 31 divided by the natural log of 10. You get about 1.491. 1.491. Okay, I think there's one more page. Yes. Okay, let's just do 2 on this page because they all have a base of an E. So let's get rid of this one and this one. Okay, so same thing. I need to get the base and the exponent isolated first. So first I'm going to subtract over the 6. Then I'm going to divide over the 1/2, which means I'm really multiplying by the reciprocal. Okay, from here, In order for my x to drop down to the front, I have to put a natural log on both sides. That allows the 3x to drop down in front. Now from here, if you have a natural log of e, you can just cancel that out because that's just 1. 3x times 1 is just 3x. So all you really have to do is just divide over the 3. So x equals the natural log of 2 divided by 3. Let's see what that is approximately. Natural log of 2 divided by 3. 0.231. So x is about 0.231. All right, last one. So I need to get this by itself. So first I'm going to subtract over the 3. Then I'm going to divide over the other 3. Okay, from here, since x is in the exponent, I have to drop that down in front, but in order to do that, I want to put a natural log on both sides. Now the exponent can drop down to the front. Now I'm going to start solving. So I'm going to go ahead and divide over the natural log of 2. Then I'm going to add over the 5. This would be my exact answer. Let's see what our approximate answer is. Natural log of 3 divided by natural log of 2. I'm going to hit enter and then I'm going to add 5. So 6.584. X is about 6.584. So when you do the homework over 5, 6, you might want to look to see where x is, because it's going to be in 3 different places. And you might want to go back and see how we solved for that x.